Welcome back to the deep dive. We're doing something a little different today. We're looking at a document that is going to land on the desk of every single A320 pilot in the world.
If it hasn't already.
If it hasn't already, yeah. It's a big one.
It's definitely one of those updates that makes you sit up and, pay attention.
Absolutely. So if you are currently flying the line, or maybe more importantly, if you have a simulator check coming up anytime after November 2025, you need to clear your schedule for the next 20 minutes or so. We are unpacking the Harmonized Engine Damage Assessment Masterclass. And while that sounds like a mouthful of corporate speak,
It does.
it represents a seismic shift in how Airbus wants you to handle one of the scariest moments in the flight deck.
It really does. I mean, it's a complete pivot in philosophy. For decades, the training footprint has been very, very specific about how we react to noise.
Yeah.
This update basically takes that training, crumples it up, and throws it in the trash.
So let's set the scene for the pilots listening. We've all been there, either in the sim or, God forbid, in real life. You're heavy, you're climbing out, maybe passing 1,500 feet, workload is high, and then suddenly you hear this massive bang.
I don't know.
Not a pop, not a rumble, a shotgun blast. The whole airframe shudders.
It's visceral. You feel it in your chest.
Right. And for the last 20 years, what was the immediate gut-level diagnosis that goes with that sound?
Severe damage.
Right.
That was the equation. Loud bang equals internal structural failure.
Right.
The engine is destroying itself. The procedure was to secure it immediately. Shut off the fuel, shut off the hydraulics, fire the bottle, kill the engine to save the wing.
It was almost a reflex. Bang means dead. But this new update, the November 2025 revision to the FCOM and FCTM, it says that reflex is wrong.
It says that reflex is actually dangerous. And I think the core mission of this deep dive is to explain why Airbus has removed loud noise from the decision-making process entirely. We have to unpack this new 2 or more rule.
That's the headline, isn't it? The removal of the noise criteria.
It is. If you open the new manual and look at the criteria for engine damage, the words loud noise or explosion are just gone.
They've been deleted.
Deleted.
Just to linger on that for a second, because I think for a lot of pilots, that is going to feel incredibly unnatural. You're telling me that if I hear an explosion off my right wing, the manufacturer's guidance is to treat that sound as what, relevant?
Not irrelevant, but insufficient. That's the key word. The sound is data, sure, but it's subjective data. It's fear-inducing data.
Okay.
It's not diagnostic data. The new philosophy is that you cannot shut down an engine based on a soundtrack. You need hard evidence on the screens.
So this is where the 2 or more rule comes in. Walk us through the high-level logic.
It's actually a very elegant logic gate. Instead of reacting to the bang, you are now required to look at the ECAM, specifically the engine warning display or the system display page. You have a list of 6 specific physical symptoms. You must identify at least 2 of them.
And if I don't see 2?
If you don't see 2, you are not, let's say, procedurally allowed to diagnose engine damage. You have to assume it's an engine flameout.
Wow. That is a massive distinction. Flameout versus damage.
It's the difference between a recoverable situation and a permanent loss. A flameout lets you try a relight. You can get that thrust back.
Right.
Engine damage is irreversible. Once you run that damage checklist, that engine is a brick for the rest of the flight.
So the default setting has flipped. It used to be guilty until proven innocent, assume it's broken. Now it's innocent until proven guilty.
Exactly. Assume it's just a stall or a flameout until the screen proves it's destroyed. The whole system is biased toward keeping the engine available.
I want to get into the weeds on these 6 symptoms because I'm in the left seat and the plane is shaking. I need to know exactly what I'm scanning for. We aren't just looking for bad numbers, right? We are looking for very specific signatures.
Correct. These are what we call hard data points. And the first one is EGT, exhaust gas temperature.
Okay, EGT. But engines get hot during a stall anyway. What's the difference here?
Huge difference. In a stall, the airflow reverses, so hot air stagnates. You'll see the EGT spike, maybe it'll turn amber. But for the damage criteria, the manual specifies a rapid increase above the red line. We are talking about a runaway thermal event.
So not just a high temp, but an uncontrollable temp.
Right. If you pull the thrust lever back to idle and the EGT is still rocketing past 800, 900 degrees, that's internal failure. That's symptom number 1.
Got it. What's number 2?
Rotation. You're looking for a significant mismatch between your rotors.
N1 and N2.
Exactly. Or, a total seizure.
Huh.
If the N1, the big fan, is showing 0 rotation while you're flying at 250 knots, that's physically impossible unless the shaft is sheared.
Right.
or if the N1 and N2 are completely out of sync with each other, especially relative to what the other engine is doing.
That's a pretty definitive one. It's hard to argue with a zero on the gauge.
It is. Symptom number 3 is vibration, and this is the one that causes the most debate in the briefing room.
Because vibration is something you feel, not just something you see.
True, but for the checklist, we are looking at the screen. We need to see a significant increase in the VIB indication. Usually this means it turns amber and it maxes out the scale.
But the manual also mentions buffeting, right?
It does. If you have a fan blade off event where a titanium blade actually snaps, the imbalance is catastrophic. The engine will shake the entire airframe. It won't feel like turbulence. It'll feel like the plane is being shaken by a giant hand.
Wow.
So if you feel that extreme buffeting and you see the high VIB on the screen, that counts.
Okay, so we have heat, rotation, and vibration. Those are the direct engine parameters. But the list goes deeper into the systems the engine powers.
Yeah, and this is where the systems manager part of your job kicks in. Symptom number 4 is oil. You are scanning for abnormal pressure or temperature.
Why is oil such a smoking gun?
Well, think about the mechanics. The engine spins on bearings. If a bearing fails, or if a shaft breaks and grinds against the casing, you get metal-on-metal contact. That does two things. It generates massive heat, spiking the oil temp, or it opens a leak path, dropping the oil pressure.
So if I see the oil pressure drop to 0 instantly, that's not a sensor glitch.
Not in the context of a loud bang, no.
That's a severed artery.
Absolutely, that's a confirmed kill.
Okay, symptom number 5 feels like the most A320 specific one of the bunch. Hydraulics.
Yes. Loss of the hydraulic system associated with that engine.
Walk us through the plumbing here. Why does a hydraulic failure mean the engine is toast?
It all comes down to the accessory gearbox. That gearbox is driven by the high-pressure shaft of the engine. It's what spins the hydraulic pump, the generator, the fuel pump.
Okay.
If the engine suffers catastrophic internal damage, say the core seizes or the shaft shears, the drive to that gearbox just stops.
So the hydraulic pump stops spinning.
Instantly. So if you hear a bang and simultaneously you get an ECAM for HYD, GSYS, low PR, or blue system, that is a massive clue. It tells you the mechanical link inside the engine is broken.
That's really helpful context. It's not just, oh, I lost hydraulics. It's, I lost the drive shaft.
Exactly. It validates the damage.
And the last one, symptom number 6.
Repeated or uncontrollable engine stalls.
Now, this is tricky because we started this conversation by saying, don't treat a stall as damage.
Right. And a single stall is not damage. A stall that clears when you move the thrust lever to idle is not damage. That's just airflow. But if you retard the thrust lever to idle and the engine continues to bang, surge, and stall repeatedly,
then the geometry inside's broken.
Exactly. If it can't hold a stable airflow even at idle, something is physically deformed. That counts as damage.
Okay, so let's roleplay this for a second. I'm the pilot flying. We are at, say, 1,000 feet. Bang! The plane yaws. I look at the EWD. I see the vibration is maxed out. It's blinking amber. The plane is shaking. Do I shut it down?
Right.
Even with that vibration?
No. Vibration is one symptom. You need two.
Okay, so I keep scanning. I look at the hydraulic pressure. It's normal. I look at the oil. Normal. Rotation is fluctuating a bit, but it's spinning. EGT is high, but it's stable.
Then you have a stall with high vibration. You do not have damage.
So I treat it as a flameout or a stall. I try to recover it.
You reduce thrust to idle. In many cases, that high vibration is just aerodynamic buffet from the stall. Once you idle the engine, the airflow smooths out, the vibration disappears, and you have a working engine again.
And if I had shut it down,
you'd be flying a single-engine approach for no reason.
That really drives it home. The 2 or more rule effectively forces you to pause.
And that's the why. We have to talk about the startle effect.
Yeah, let's dig into that, because the manual spends a lot of time justifying why they made this change. It seems like they're trying to solve a biological problem with a checklist.
They are. The reality of a compressor stall, that shotgun, bang, it's terrifying. Physically, it's just air reversing direction. The high-pressure air in the combustion chamber escapes forward, out the intake. It's a backfire.
And it shoots flames.
Oh, yeah. If it happens at night, you might see a 20-foot flame shoot out of the engine. Passengers will scream. The cabin crew will call you. It looks like the apocalypse.
But the engine internals are fine.
Often, yes. The blades are intact, the shafts are straight. It's just a burp, a very violent burp. But because of the startle effect, that adrenaline dump pilots were reacting to the violence of the event.
They were shutting down engines that were perfectly healthy.
And the data backs this up. This is what drove the update. Airbus looked at the history of severe damage shutdowns. A huge percentage of them were performed on engines that had nothing wrong with them other than a temporary airflow disruption.
So we were throwing away perfectly good thrust because we got scared.
Harsh, but true. The new procedure is designed to bypass your amygdala, your lizard brain that wants to run away, and engage your prefrontal cortex. By forcing you to count to 2, I need symptom A and symptom B, it forces you to slow down. It forces you to look at the data.
It's a buffer, a mandatory pause.
Exactly.
Okay, I want to transition to the instructor's corner because all of us A320 drivers are going to see this in the sim, and instructors love traps. What are the specific scenarios they are going to use to catch us out?
The classic one is the shotgun trap. The instructor will trigger a stall that is programmed to be incredibly loud. The sound files in modern sims are really good.
And the motion platform kicks you sideways.
Right, so you get the bang, the yaw, the shake. The trap is that the pilot yells, "Damage," and reaches for the master switch. Fail.
So what's the correct flow?
Hands off.
Yeah.
Read the screen. N1 is spinning. EGT is controllable. I only see vibration. Therefore, it's a stall. Thrust levers. Idle.
And usually in the sim, once you pull it to idle,
The noise stops. The vibration stops. And the instructor smiles and says, "Good job. Now let's try to restore thrust."
there is another trap mentioned in the update regarding low-speed scenarios. This one feels a bit more technical. Something about the N2 indication.
This is a gotcha for the systems geeks. It happens usually on the ground or during a low-speed RTO. If the engine is spinning very slowly, the N2 sensor, which measures the high-pressure compressor, can be unreliable.
Unreliable how?
The sensor technology at the bottom of the RPM range isn't great at distinguishing between a slow wind down and a seizure. It might show 0 when it's turning, or it might show some rotation when it's actually sheared.
So if I'm taxiing or I've just rejected at 40 knots and I hear a bang, I can't trust the N2.
You shouldn't rely on it as your sole piece of evidence. You need to cross-check.
What's the cross-check?
Hydraulics and oil. Even at low RPM, if the shaft is turning, the hydraulic pump is turning, you will have pressure. If the N2 looks weird but your green hydraulic system pressure just dropped to 0, that's your confirmation.
That's a pro tip right there. If you're low and slow, look at the system pressure, not just the RPM.
It's about triangulation. Don't trust one sensor when you're outside the normal flight envelope.
Let's zoom out and talk about the golden rules. We hear fly, navigate, communicate, so much. It's almost background noise. But in this specific context, the engine explosion, how does that hierarchy apply?
It applies because this new procedure takes time. And time is the one thing you feel like you don't have when things are exploding.
You feel the need to rush.
But you must not. Golden rule number 1, fly the aircraft. When that bang happens, the plane is going to yaw. It's going to roll. If your head is buried in the engine display counting symptoms, you're going to lose control of the aircraft.
So step 1 is purely stick and rudder.
Step 1 is stabilize, center the beta target, get the wings level, then check the FMA. The flight mode enunciator. Is the auto throttle keeping the speed? Is the autopilot fighting the yaw?
And only then do you look at the engine.
Exactly. The manual is very clear. Do not rush the fire push button.
That's a quote we should put on the dashboard. Do not rush the fire push button.
Well, think about it. The engine is on the wing. It's outside the pressure hull. Even if it's burning, it's not burning you. You have time.
I think that's the hardest part to internalize. We are trained that fire is immediate death. But on a modern airliner, an engine fire is a manageable condition.
It is. A stall is dynamic. The thrust is fluctuating. The plane is yawing. You need to fly. A destroyed engine is static. It's broken. It's not going to get more broken in the next 10 seconds. So take the time to diagnose it correctly.
So the sequence is fly the plane, read the FMA, calmly assess the EWD for 2 or more symptoms, and then make the decision.
That is the professional sequence. And notice the word calmly. The decision to declare damage and shut an engine down for good should be a cold, calculated decision based on data, not a hot reaction based on noise.
Okay, let's wrap this up. The main takeaway for the whole A320 community, the era of bang equals shutdown is over.
It's over. The loud noise criteria is dead.
Gone. You are now looking for 2 or more hard data points on the ECAM.
EGT runaway, rotation mismatch, vibration, oil, hydraulics, or repeated stalls. Pick any 2.
And if you don't see 2, you keep the engine in the fight.
Assume flame out. The penalty for being wrong on that side is much, much lower.
And we fly, we navigate, we communicate, we do not rush that fire button.
Verify, verify, verify. Trust the EWD, not your ears.
This has been a really crucial deep dive. I mean, it's not just about knowing the checklist, it's about having the discipline to execute it when your heart is pounding.
And that's really the final thought, isn't it? In the heat of the moment, with a loud explosion in your ear, do you have the discipline to trust the screen over your senses? The new procedure isn't just a check of the engine. It's a check of the pilot's ability to remain calm.
Couldn't have said it better. Thanks for listening. Study the manuals and fly safe.
Safe flying, everyone!